Welcome to EEMS 272. In this video, we will describe the graphical user interface for the modeling of zooplankton in the EFDC Water Quality Module. From EEMS 10.3, users can include an unlimited number of zooplankton groups in a water quality model. This feature is the first step towards modeling the effects of eutrophication management on top-level predators in EEMS. Let's get started. As we have developed the water quality model in previous videos, we have selected the kinetic module option and filled the parameters for nutrients and algae. The next step is to assign parameters for zooplankton. To do this, the user can go to the Biota tab and check the Use box to activate the zooplankton options. After that, click on the Modify button to bring up the options form. From the top of the zooplankton group form, the user can input the number of zooplankton groups that will be simulated. Click on the numeric up-down button to switch between the groups. The user can give a name to each zooplankton group, as well as delete it. To give an example, we will set up the parameters of zooplankton group 1. Similarly to algae, zooplankton parameters are classified into its kinetic processes and displayed in different tabs, including General, Grazing, Basal Metabolism, Predation, and Death. In the General tab, the user can set up stoichiometry parameters for nitrogen, phosphorus, and silica to carbon ratio. If the model simulates different zooplankton groups, predator or prey groups can be identified by checking the option box. Zooplankton can graze on algae groups, organic carbon, and prey on other zooplankton groups if the group is identified as a predator in the model setup. Parameters representing these sources of food can be edited from this tab in the Utilization of Food by Zooplankton. In the current EFDC version, the grazing process is incorporated into the growth rate of zooplankton by a maximum ration formulation. The grazing parameters include a carbon threshold below which prey is not utilized. The prey density at which grazing is halved and maximum ration of zooplankton can also be set in this tab. The zooplankton growth rate is also controlled by temperature. Growth increases with temperature until an optimum is reached, after which further temperature increases will inhibit growth. The parameters to determine the temperature effects on zooplankton growth can be defined through the optimal temperature options. Basal metabolism in the EFDC Water Quality Module is represented as an exponentially increasing function of temperature. From the Basal Metabolism tab, the user can enter the basal metabolism rate at reference temperature, as well as parameters for the temperature function. Because zooplankton returns some nitrogen and phosphorus state organic minerals to the environment, the user can edit the fraction of return nutrient components from the basal metabolism nutrient fractions. Similar to the basal metabolism, zooplankton predation rates can be represented as an exponentially increasing function of temperature. In the predation tab, the user can enter the predation rate as well as the temperature parameters. Predation nutrient fractions are grouped for each nutrient, including carbon, nitrogen, phosphorus, and silica. Zooplankton are subject to mortality at low dissolved oxygen concentrations. From the Death tab, the user can enter the critical value of DO concentration as well as the rate of zooplankton death. Similarly to zooplankton predation, the death nutrient fractions are grouped for each nutrient, including carbon, nitrogen, phosphorus, and silica. At this point, the parameters of the current zooplankton group are completely set up. The user can repeat this process for other zooplankton groups in the simulation. Thank you for watching. You can find the link to the next video below.